So I'm going to start my statement with that. Ready? With 95% confidence. And then I'll put a comma. Does that sound good? All right, with 95% confidence, comma. So we got to state our confidence level. Oh, you bet all the articles do the same. When you read that at the end, they put it way at the bottom of the article. With 95% confidence, the proportion of voters who believe the issue of abortion is important. By the way, I'll write this another way too. I want to take all this out. Is important when voting in the next election. Or you could say, I said believe, you could say who consider. If you like that word better, who consider the issue of abortion. When voting in the next election is between which two numbers?
0.672.
0.672, you could do this. You like to write percentages. And what's the other number?
72 minutes.
It's somewhere in there, it's trapped in there. So with 95% confidence, we know the proportion of voters is in here. Hey, I'll abbreviate this too, because some students, I went back and referred to the actual question and stuff. Some students, Mia, will just go, can I just say the population proportion? You can. I'm fine with that. I really am. You write that on your paper, I'm fine with that. So once you're done talking, I'm going to write this another way, just an abbreviated way, which you might be fine with, but when I write it, I'm going to be careful that I don't mess up the wording. So I'll talk about that as well. All right, with 95% confidence, the proportion of, I put voters, it was really what kind of voters? Likely, so I can even put that in, the proportion of likely voters who consider the issue of abortion important. I take that off. Who consider the issue of abortion important when voting in the next election is between these two numbers.
Is this
That'll work.
Is this 95 like what you do it on the empirical formula that we had that thing?
That's right.
So you have like 68, 95, and 99.
That's right.
Three confidence.
And we're doing the two standard deviations away from the mean. Exactly.
Okay.
Very good. Sometimes they'll go for that 3 if it's something, I don't know, in the medical field. And you just want to be really, really sure, and they're going to bump it up to what?
One more.
99% confidence. Hey, you know what probably happens to the interval though? When you go for more confidence, right? It what? It usually spreads it out more. Hey, well, I'm just going to write this. You might find this easier. Interpret this. With 95% confidence, the population proportion is between (67.2%) and 72.8%. Do you find that easier?
Yeah, that's much smaller.
You go, yeah, that's it. That's really what we're saying. Because the question's up there. You don't have to go repeat everything that was up there. We know that. But what's so important, everyone, don't say sample proportion. See, we're 100% confident about the sample. We did it. We got what? We know we did that, right? Yeah, we got 7. That's more 100% there. We were trying to estimate what? This, with a certain level of confidence. Hey, by the way, sometimes people, they go, I don't understand what this means. What do you mean by 95% confidence? So, can I explain that to you? You don't have to write this down. I think it's important, as a student, what does this mean? 95% confidence. This is what it means. Everyone, if I repeated this and did this 100 more times, 100 more times in the next month, I just kept calling 1,000 people every day with a team of people. 1,000 people, 1,000 people, 1,000 people, 1,000 people, 1,000 people, 1,000. I did this 100 times. Everyone, 95 out of 100 of those, all right? 95 out of 100 of those would have proportions between these two percentages here. That's what it means. Can I say that again? Just so you get an idea of what I'm talking about. Okay? Ready? You go, what does this mean with 95% confidence? Because we're trying to estimate what's going on with millions of people, right? Throughout the entire United States. This is what I'm saying. If I continue to do this, and I did this 100 more times, I called 1,000 people today with a team of people tomorrow, the next day, the next day, the next day. I did this, 100 times. 95 out of 100 of those what? Those polls would have percentages between what? 67%, and that's what it means.
So that means,
Which really means it's somewhere in there.
that means 70 is, sorry, 0.70 is like a mean then.
That's right. It really is. Smack dab in the middle. We use it as the mean, as the middle. And we use it as this point estimate with some level of confidence.
Yeah,
Isn't that cool? Everyone, great job with this. Great job with C. I bet you rock and roll with D. I would like you to calculate the margin of error. So I'm just going to put MOE. Can you find the margin of error for this problem? And you look back at your work. And if you wrote it both ways, me, that's going to be a piece of cake, right? If we wrote it both ways, this is going to be a piece of cake. Brianna, remember we wrote the confidence in this way and this way? The margin of error is that number after the plus minus. It's hard to see it here, right? To do it here, you'd have to probably draw out a picture and take this and subtract that. But isn't it sitting right there? So that's why I encourage you to write it both ways. But you don't have to. I mean, you might find yourself just being comfortable writing it this way, right? And then you might go off to the side, maybe make a picture and just go, oh, I just gotta take this endpoint 0.728 and subtract the p hat in the middle and I can figure out what the margin of error is. Because that minus that will give you this what? 0.28. Hey, when you write this on your test, this is great, but you know what you probably should put in front of it? Plus or minus. Okay, I won't take off if you forget the plus minus. Or if you don't even want to do it. The articles even do it. I know, but even the articles put the little plus minus. Because they're saying margin of error means you what? You add it, and what else do you do? You subtract it. But you'd still say mathematically, hey, the margin of error is about close to, if we round that, what would that be, 3%? By the way, that's what the article said. Makes sense, everyone. You got readers reading this article, of course, right? And your typical reader, 3% sounds better than what? 0.028. The more numbers you get in there, it gets more confusing. So they use 3% in that article. In fact, they're always trying to get this 3%. It just seems to be, okay out there. As long as you get about 3%, that's cool. Everyone all right with that? All right, now this is fun. We're going to get into this discussion now, everyone, of why they're doing like 1,000 people. And they're getting this margin of error like 3%. And maybe they could get it a smaller margin of error. Don't you all agree the smaller the margin of error, the better? You get a better estimate of what? This guy, you tighten it up. Tighten up that interval so we can really get an idea what this is. I mean, that's pretty good. It's somewhere in here, right? It's in there somewhere. But if we want to tighten this, so that's the question, right? I want Rasmussen reports. Desires to, see this interval right here? Decrease the margin of error. I want this margin of error smaller. I want this interval tighter, right? I want to shrink this interval, tighter numbers, close together. We're asking for desires to decrease the margin of error. What do they have to do? What should they do? What should they do to decrease that margin of error? All right. Question mark?
Increase M.
That'll do it. All right, how'd you know that? That was really good.
It's inversely proportional, so n is at the bottom, right? So
Yeah, brilliant. And when you answer this question, I want you to see this. We're gonna increase the sample size. That's the answer. This formula, I'm gonna write it again over here. Look at this. What does the CI equal to? P hat plus or minus Z times the square root of this P hat times 1 minus P hat all divided by n. We're saying in this math formula, if you make this number right here bigger, it makes this number smaller. That's what happens in fractions. Art mentioned this word inverse. He's talking about this denominator here. If you make that number in the bottom bigger, it makes this whole number smaller. You want to see it? Watch this. 1/2, everyone. What's that number as a decimal? 0.5. Okay. Now watch this. What's 1/20? I just jacked that up a little bit, right? Guess what happens to this decimal?
0.05.
It gets smaller. You see what I mean? You explode the denominator, it makes it what? It makes this get what? Smaller. You make the denominator bigger, it makes it right. So the answer to this question, everyone, we'll keep it simple. Increase the sample size. Increase the sample size. Increase the sample size. We're going to increase the sample size. All right. Increase the sample size. Which is n, right? You know what some students do on a test? They just draw an up arrow, and then they put n. That's okay. I'm serious, right? That's what you mean. Hey, what are you doing with the n? You're going to what?
Increase it.
Now, here's what other students said. These are all appropriate. You're going to have to call more people than 1,000 people. You're going to have to contact more than 1,000 people. That's what they mean. That's what we mean. You need more people in this. So yeah, why don't they do that? Oh, and here comes that discussion I was seeking. Why don't they just call 5,000 people and all that stuff? Why don't they just do it? You'll get it what? Don't we want a smaller margin of error? Yeah. It costs money, doesn't it? That's the idea. This stuff, the people are being paid to make these phone calls, right? It's a business. They got people working. And sometimes just to get more people out of here and get more phone calls, that requires many more days, many more man hours, etc. Costs a lot more money. All right? That's why. At least one major reason. But everyone seems to be okay in these political polls lives with 3%, which we got here. But now, I'm going to get the letter F. So this is important. We're going to pretend that Rasmussen Reports does desire to get this smaller margin of error, and I'm going to give you the error, but you and I are going to do a backwards math problem, figure out, well, what's the sample size needed. And you'll see I got, in your practice problems, I have many problems in the textbook already picked out for you on that list that are good practice problems for this, all right? So I'll erase this top part so there's enough room, and I'm going to call this letter F, okay? Determine the sample size. Necessary. So what I'm saying here, I'm going to ask this question is, Rasmussen, let's pretend they're going to go out and they really want to get this daggone number right here down to 2%. Okay? So the question is going to be regarding to how many phone calls they're going to make. How many voters are going to have to contact. So determine the sample size, which is what letter?
N.
N. So you're going to figure this out as N. Determine that sample size N. Necessary to obtain a margin of error, and we need to just put MOA, or ME. ME for margin error, right? Margin of error. Within 0.02. Right now it's at like 3%, when it was 2.8%. Determine the sample size necessary to obtain a margin of error within 2%. Okay. You ready to roll? Oh, and I gotta state, we go, well, what confidence? Everyone, we're gonna use the same confidence level. So this is still with 95% confidence. All right? I'll put that in parentheses. With the 95% confidence level. So I didn't want you to think, everyone, do we have to change the z-score? Nope. We're still going to use the same z-score with the what? What was the z-scores? -1.96. So we're not playing around like, do we want 98% now? No, same confidence level, right? Same confidence interval, 95% confidence. Are you ready for this? Can I erase this down here? Are you sure? Okay. This is always interesting. We'll look out here. Who likes algebra? Right, now do you notice not every hand went up? You've heard, that's okay. And when you heard me say this at the beginning of the year, I said, that's like 2 times in this class we gotta do some algebra. Here's one of them. Now, if you're an algebra hater, there's nothing wrong with that. What we're gonna do at the end is, we'll record a formula, and then you're just gonna remember the formula. But would you make a note when we get that formula? It's not on the formula sheet, okay? So just say, oh, I'm just gonna remember this. So if that's my point, if you feel like, I don't like algebra, okay, we'll produce a formula that you can use. But I'm gonna treat this as, you and I are gonna do a little algebra. So I'm trying to determine a sample size necessary, which is an n, to obtain a margin of error within 0.02. So I'm gonna do this, and when I gotta go over this math formula here, and I gotta extract the part of this formula here, which dealt with the margin of error. Where was it? Ooh, Brianna, excellent. It's this part. See this? Everything in there, I'll take this out of the way so it doesn't look confusing. This is your method. So that's the part I gotta write down. I'm gonna write that down. And I'm gonna say, margin, this is what I'm gonna do. I'm gonna do an algebra problem. Margin of error equals z, and then there's a square root, and there's a p hat, and there's a 1 minus p hat, and then there's an n. And hey, for the algebra haters, that's not the formula I'm talking about. Don't worry, we'll get a way better one. That's not it. That's not it. So margin of error equals z times all that. All right, let's fill everything in. You'll notice, everyone, the only thing we don't know is that. All right, what's the margin of error now?
0.02.
Good. Now, hey, just in case this happens on the test, if you accidentally right here, right, the original, remember we got 2.8% earlier? You do all your math, I'll tell you what you get for n, you're going to get the 1,000 people. Remember with 1,000 people, it came out to what? 2.87. This question is, what would be the necessary sample size to get it down to